In this video, I'm going to show you how a facade sound insulation measurement is made. And with it, to do that, I have this one. It's a Norsonic wedge-shaped loudspeaker. It's a noise source. And this one, it says here on the back, let's see if you can find it. Yeah, 45 degrees. So this little speaker shoots sound. It's a directional speaker, because usually when I do sound insulation measurements, I have an omnidirectional speaker that is a point source, emits sound in every single direction. This one, however, focuses the sound, because if you're going to do facade sound insulation measurements, let's say you have well, let's just walk through the principles first. If you do inside a building, you have a sound source in one room, emit sound, you measure the sound pressure level in this side, and then you measure the sound insulation, the sound pressure level in the second room, and then you can look at the difference between these two, LP1 minus LP2, and you will find out how many decibels of reduction did you get here. That's the basic principle. You also do some correction for the properties of the room, but this is what it's primarily about. So when you do facade insulation measurements, it's quite similar, so that you have... Okay, so let's see if we can paint a little house in a good way. Two-story house, this is a bit larger one. We got some windows. And then you can place this wedge-shaped speaker that I showed you on the ground, like so. And then it's gonna emit sound like so, and expose an area of the facade. So inside here might be a bedroom, for instance. And then you can do the same thing, that you measure the sound pressure level outdoors, which would be like, if you look at it from the side. So here's the window, and then you have sound from the loudspeaker coming here. And then you measure the sound pressure level outside, LP out, I call that one, and then you have LP in. And then you can look at the difference between these two and find out whether your windows are if they are good or bad. So that's a quick way to explain it. Because the reason that we need two separate sound sources is that in this case, actually I draw this one as it should be an omnidirectional loudspeaker. So it looks like a ball with loudspeaker elements all over it. And this one emits sound in all directions at once. And the reason that we want that when you do inside a building is that you will get sound transmission through the directly separating construction, but you will also get flanking transmission like this. It's going to hit the ceiling and travel and come. And you will hit the walls in the same manner, so it comes this way. And also, if I could draw in 3D, it comes out and back in, so you get... Better to do it like a little 3D sketch, actually. That's gonna be more pedagogical, I hope, at least. Oops. So, and then there we have it. So you're gonna get one direct sound, and you're gonna get through the floor, through the ceiling, through the wall, and through this wall as well. And that's why you need an omnidirectional speaker, because if you have a directional speaker there, you will only excite one of these surfaces, and your measurements will be incorrect. But when you go outdoors, I mean, that would just be, if you put an omnidirectional source here and send sound in all directions at once, that would just be a waste of energy. And also, another important thing with this wedge speaker is that you wanna, if you have a surface partition here, like in this case, let's choose the rainbow pen. Here's our surface partition, and this is the one that we wanna find out what is the sound reduction index through this one. Then we want to have, if possible, a pretty even sound field, so that you have, let's say you have 90 dB all over this little thing. But if you have the Omni speaker, you might have lower sound pressure in the corners and stronger in the middle, because if it's coming like a spherical wave like this and it hits a flat surface, you won't get the same sound pressure because the travel distance will be different. This one will have traveled further before when it hits the surface. So that's another reason why you need a special kind of loudspeaker. So short little introduction to facade sound measurements. And in today's video, I'm wearing blue, white, orange, and green, which is a good combination. All these colors harmonize with each other. And as always, green eyes, green pants. Always go with your eye color if you're out of inspiration, because that always works. It's going to look nice no matter what you do. So, see you later.